This problem will be an exercise in using those properties of integrals that we just saw in the notes. Okay, so we are given that the integral from 0 to some positive number, any positive number you want, a, of a function f of x is given by this formula 2a squared. Okay, so for example, we could say a equals 1, right? And then this formula is telling us the integral from 0 to 1 of f of x dx is 2 times 1 squared, and do the arithmetic on that, you get 2. You could also do maybe a equals 2, right? Then you're integrating from 0 to 2, the function f of x, and here you're plugging in 2 for a now, so you're getting 4 squared, and then times 2 gives you 8. And one last example here, a equals 4, the integral from 0 to 4 f of x dx is 2 times 4 squared, so 4 squared gives me 16, times 2 gives me 32. Okay, so this is an example of how you're using this formula, right? You're just plugging numbers into a and then plugging them into this formula. So someone did the work to figure this out, right? So we're given this. Okay, so we're going to use this freely. And we're asked to find this integral now. Okay, and we're going to use some of the properties of integrals to rewrite that. So let's look at that. So if we look at the integral from 1 to 4 of 3 f of x plus 2 dx, rule number 4 of integrals says that we can split this up into two pieces, right? We have this plus this. So we can split this up into two pieces according to that rule. So this is the same as the integral from 1 to 4 of 3 f of x plus the integral, so I missed the dx on here, dx plus the integral from 1 to 4 of 2 dx. Okay. We have another rule, so rule number 3 in those properties in the notes says that I can take this 3 and pull it on the outside of the integral. Okay, so this is the same as 3 integral from 1 to 4 of f of x dx. And I'll remind you that one of the problems in the previous sections was a now you try problem that essentially said find the integral from a to b of any old constant c, right? So that was a problem that you did, and the moral of that problem, the idea behind it, was essentially that if you integrate a constant, the integral is going to be whatever that constant was, so in this case 2, times the length of the interval over which you integrated. So here we're integrating from 1 to 4, so the length of this interval, right, how long does it take to go from 1 to 4, should be 3, right? So from 1 to 4, that should be 3. So the integral of a constant is just that constant times the length of the interval. Okay, so this integral is going to give us this number, right, which is 6. So now the only thing left to do is to figure out this integral, so the one from 1 to 4, right? So integrating f from 1 to 4. And for that, we're going to add this stuff up here, right? So the formula that we were given. Okay, so let's work on the next page and see what we can get. So here we're looking for, so we want the integral from 1 to 4 of f of x dx. And I like drawing a number line for this to get an idea of what we have and what we want. So we know the integral from 0 to any number, right? So we were given that the integral from 0 to any number a of f of x is given by this formula 2a squared. Okay, so I know, for example, the integral from 0 to 4, right? I know this, right? So we have this. I also know, for example, the integral from 0 to 1, right? So I know the integral from here to here. We also have this. What I want is the integral from 1 to 4, right? So I want to know what is the area in that little interval, right? So what is the integral of f from 1 to 4? So you might be able to see how we're going to piece this together. So one of the properties of integrals, so property number 5, says that if I integrate from 0 to 4, so if I integrate from 0 to 4, that is the same as integrating from 0 to 1, and then adding the integral from 1 to 4. And so this is essentially saying that you can integrate in steps, right? So if I want to go from 0 to 4, I can just go from 0 to 1 and then from 1 to 4, right? So integrate from 0 to 1 plus integral from 1 to 4, right? And that gives me this full integral from 0 to 4. So now notice we know what this number is, right? We actually calculated it on the previous page. We also know what this number is, right? We also calculated that on the previous page. And this number is what we're looking for. Okay? So let's manipulate this equation so that we have this on one side and then these other two terms on the other side. So if we do that, we're going to get the integral from 1 to 4 is the same as the integral from 0 to 4 minus the integral from 0 to 1. And because I just moved the x, this term right here, over to the other side, right? I subtracted it. So then I get this. And once again, I know what these two numbers are. We calculated those. Okay? So the integral from 0 to 4, that was 32. And we can check back. So the integral from 0 to 4 is 32. The one from 0 to 1 is 2. Right? So here, this term should be 32. And then minus this term, which should be 2. So that means the integral from 1 to 4 is actually 30, right? So that's what I get for this integral. Okay? So we can go back and plug this in, this 30 in. So we're going to get, this is equal to 3. We just figured out what this integral is. That's 30. So we're going to write in times 30 plus 6. So do the arithmetic on this, we get 96. Okay? So in the end, the integral that we're looking for, this one right here, is the number 96.